Example 3. The linear function m equals 50 minus 9d represents the amount m in dollars of money you have after buying d DVDs. Letter A, find the domain of the function. Is the domain discrete or continuous? And explain. So, first things first is we have to figure out, well, what is representing the domain? So if you think about the domain is all of your input values. So if I go back and I look at my function, it looks like to me that D, or our DVDs, is going to be our domain. So the domain is number of DVDs. Now, if I start looking at a table here, which we're going to use here in a minute, your domain is your number of DVDs, which means your range is going to be the amount of money. So the amount of money that you have left in your pocket is going to depend on how many DVDs you buy. That's another way of thinking about it. Now, it wants to know, is this domain discrete or continuous? Well, think about the number of DVDs. Can you buy DVDs in like whole number increments? Or can you buy them in like broken up pieces? Can you buy 1.5 of a DVD? And the answer to that is no. If you walk into a store and you break a DVD in half, they're going to yell at you until you have to buy the whole DVD. So this is going to be discrete, and the reason is because you can't buy parts of DVDs. You have to buy them in whole increment numbers. You can buy 0, 1, 2, 3, etc. Now, find the domain. That's your DVDs. Is it discrete or continuous? We said it was discrete. Letter B, graph the function using the domain. So we're going to finish our idea here of domain. And the number of DVDs that we can buy, well, we could buy 0. Maybe 1, maybe 2, maybe 3, maybe 4, maybe 5, maybe 6. I'm running out of room, so I'm going to stop there for now. And then I'm going to figure out, well, if I buy 0 DVDs, how much money do I have? So if I come back up to my function, I have 50 minus 9d. So I'm going to start with 50 minus 9 times 0, which is $50. Then I'm going to do 50 minus 9 times 1, which is $41. 50 minus 9 times 2, which is $32. 50 minus 9 times 3, which is $23. 50 minus 9 times 4, which is $14. 50 minus 9 times 5, which is $5. 50 minus 9 times 6, which is negative $4. Well, what happens when you have negative $4? That means you didn't have enough money to actually buy that DVD. So actually, we can't buy 6 DVDs. We can only buy up to 5 because we only have $50, so we don't have enough money to actually buy the 6th one. So more specifically, when it says find the domain of this function is 0, 1, 2, 3, 4, 5. That's all the higher we can go. Then if we're going to graph the function, we've got 0, 50. So we go to our graph, over 0, up 50. Excuse me. We have 141, over 1, up 41. 232, over 2, up 32. 323, 414, 5, and it would look just like that. Do not use a line to connect your dots because this is in fact a discrete domain. So if you put a line through those, you would be telling me that the number of DVDs could be 1/2, 1.5, 2.5, but that's not true. So do not connect that line. Number 4, is the domain discrete or continuous? Explain. So input, number of stories. Now when they're talking about number of stories, your output is the height of a building, so it's talking about the number of stories in a building. So if the building has 1 story, it's 12 feet high. 2 stories, it's 24 feet high. 3 stories is 36 feet high. Is this discrete, or could there possibly be 1.5 stories, or 2.5 stories, or 1 1/3 stories? Well, this is definitely discrete because we don't build buildings with 1.5 stories. Otherwise, a very short person might not be able to fit. So when you build a house or build a building must have whole numbers for stories. Number 5. A 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. The number g of gallons remaining is a function of the number m of minutes. First of all, letter A, does the situation represent a linear function? Explain. So remember, a linear function has to have a constant rate of change. Is the water draining out of the bathtub at a constant rate? The answer to that is yes, because it says that it's draining out at a rate of 2.5 gallons per minute. That's constant. It's always doing that. So does it represent a linear function? Yes, because it has a constant rate of change of, and I'm going to write this and then I'm going to change it, 2.5 gallons per minute. Now, the reason I said I'm going to write it and then I'm going to change it is because it says that the water is draining out of the bathtub. Okay, like think about that. You got a bathtub, it's draining down, out of the bathtub. So is the water like increasing in the bathtub or decreasing in the bathtub? And it's decreasing in the bathtub, which means actually our rate of change is negative because the amount of water in the bathtub is going down. So we have negative 2.5 gallons per minute. Letter B, find the domain of the function. Is the domain discrete or continuous? Okay, so first of all, we have to think about the domain. So is the domain the number of minutes or is it the number of gallons? So we've got the number of gallons remaining in the tub and we have the number of minutes. I want the domain, which means I want the independent variable. Well, that's going to be the number of minutes. Because the number of gallons, this depends on how long the tub has been draining. If it just started draining, it still has probably 20 gallons of water in it. If it's been draining for a long time, most of that water is probably gone. So the gallons depend on time, which makes the time the domain or the independent variable. Now, it wants to know, so we know that the domain is the minutes, and we'll get more specific here in a minute. Is that going to be discrete or continuous? Well, that's going to be continuous because as the water drains out of the tub, it's at 20 gallons, it's at 19.9, it's at 19.8, it's at 19.7. It doesn't all of a sudden jump from 20 gallons to 19 gallons. You don't just like, if you were using a bucket, like if you had a bucket and you like dumped it all out at once, but as it drains, it just drains continually. So I'm going to write tub drains continually. Now, last but not least, and we're going to go back and revisit this domain a little bit more, it says graph the function using the domain. So, first of all, the domain we said was the number of minutes. So I'm going to put minutes here. The range are the number of gallons. So I'm going to put gallons here. The minutes, if we think about this, is going to start at 0 minutes, and they're going to go to 1 minute, 2 minute, 3 minute, 4 minute. But the question is, well, how many minutes is it going to take for the tub to drain completely? So I'll ask that another way. If the tub is drained completely, how many gallons of water are in the tub? Well, that would be 0. So actually, before I even do that, I'm going to start with the equation. So number of gallons is G. That's my dependent variable. So my G depends on what is happening with my time. Well, we said that the tub is draining at 2.5 gallons per minute, and we said that that was negative 2.5 gallons per minute. So far, this is our function. But how many gallons were in the tub to start with? Well, that was 20. So I'm going to add 20. Now, back to my question. This function will represent how many gallons are in the tub at any given time. My question was, okay, well, how many minutes is it going to take for the tub to drain completely? Well, in order to do that, I want to know, well, the gallons has to be 0, because if the tub is drained completely, there's no gallons. So 0 equals negative 2.5 m plus 20. If we solve that, we're going to subtract 20. Negative 20 equals negative 2.5 m. Then I'm going to divide both sides by negative 2.5. And I'm going to get 8 equals m, which tells me when I start at 0 minutes, my tub is at 20 gallons. And when I end at 8 minutes, my tub is at 0 gallons. So ultimately for letter B, the domain of my function, my minutes is from 0 minutes to 8 minutes. My minutes have to be greater than or equal to 0, but less than or equal to 8. So that would be my final answer for my total domain. Now we have to graph that using the domain. Option 1, we can just connect a line. So let me find my line here. And there we go. Option 2, we could actually make a table. Which I think is a good thing to look at. So we've got our minutes, we've got our gallons. At 0 minutes of draining, we start with 20 gallons. Then we have 1, 2, 3, 4, 5, 6, 7, 8. And they told us that it's draining at 2.5 gallons per minute. So all I'm going to do is I'm going to take 20 minus 2.5, which gets me 17.5. Then I'm going to minus 2.5, which gets me 15, minus 2.5, which gets me 12.5, minus 2.5, which gets me 10, minus 2.5, which gets me 7.5, minus 2.5, which gets me 5. Do it again, we're at 2.5. Do it again, we're at 0. So if you take a look at our graph, I'll just check a couple. We said at 2, we should be at 15. 2, oh, look at that, we're right there at 15. 4, we should be at 10. Oh, look at that. 6, we should be at 5. And then on this example, we specifically connected with a line because we said it was a continuous domain.